Hello, and welcome back to Shiksha de Costa. Today we're going to learn how to graph a quadratic relation from standard form. Today we're going to look at how to use the information provided by a quadratic to graph it. And by the end of this, you should be able to sketch or to graph a quadratic that's given to you in y equals ax squared plus bx plus c, which is called standard form. To start off here, I'd like you to graph these three using a graphing software like Desmos or even your graphing calculator and say, what do you notice? Well, this is what the graphs of these three look like. And if I were to try to notice something, the one thing that would immediately pop out to me is these three are all the same. Each of these has the exact same points in the exact same places. And another thing yet to notice is that, well, some of the numbers actually appear in the equation and on the graph. And that's something that we sort of expected, right? We know that in vertex form, -3 and -1 would be the vertex. In factored form, -4 and -2 would be the roots or the x-intercepts or the zeros. And in standard form, we can even pull out the y-intercept from that c value. All three forms of a quadratic function give you information about at least one point on the graph. If you are given an equation in standard form, you can find the y-intercept just by looking at the constant. If you wanted to find more information, you could complete the square to turn it into vertex form, and then h and k are just the values of the vertex right there. If you're given an equation in vertex form, you can always go backwards to standard form, and it's much easier than completing the square. All you have to do is expand and simplify, right? Just turn this into standard form. To turn anything into standard form, you always just expand and simplify. And if you wanted to find out the x-intercepts, you could take that standard form and you can factor it using whatever method works best. Either that's difference of squares or perfect square trinomials or decomposition or the sum product rule, whatever have you. And that turns it into factored form. And from factored form, you can find out the zeros just as any two values of x that make either of these two factors equal to 0. And if you wanted to go back, you would just use FOIL, or in other words, again, just expand and simplify. And this gives you a total of 4 points. And of course, the more points you have, the easier it is for you to sketch an accurate parabola. Now, the only thing that I would say here is not every quadratic actually crosses the x-axis. So not every quadratic even is factorable, and even some of the ones that do cross the x-axis are not factorable. So we kind of have to rely a lot on standard form and on vertex form because they are applicable to every single quadratic in the real numbers. So not every quadratic function, like I just mentioned, will have real zeros, so factoring is not always going to be an option. Can you sketch the graph of y equals x squared plus 6x plus 8? Pause the video here and see if you can use the techniques you've learned to plot as many points as you can. Well, this is in standard form. So one thing I can certainly tell you is that the y-intercept for this quadratic is going to be at 0 and 8. And I'll put that on my graph right there. Now, if I were to take this and factor it to factors of 8 that add up to 6, 1 plus 8 is 7, is 9, so that's not 6. 4 times 2 is 8, 4 plus 2 is 6. Oh, that works. So this can easily factor into x plus 4 times x plus 2. And so -4 plus 4 would give me 0. -2 plus 2 would give me 0. And those are my two zeros. So I'll plot those on my graph as well. -4 and -2 are my x-intercepts. Then starting from here, I can complete the square. So I can take my b value divided by 2 and square it, and that's 9. Add and subtract 9 just before the constant. Factor this into a perfect square trinomial, which is always going to be x plus half of b. So x plus 3 squared, and -9 plus 8 give me -1. And using this vertex form, I can say, oh, okay, the vertex is going to be right here at -3 and -1. And this is actually the same quadratic that we had during our minds-on exercise there. And this creates the opportunity for me to very smoothly draw a parabola through these points. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.